Next, move to the introductions. What is gravimetric analysis? Gravimetric analysis is a quantitative method of quantitative chemical analysis in which the constituent salt is converted into a substance that can be separated from the sample and weighed. There are 4 types of gravimetric analysis. The first one is volatilization gravimetry, electrogravimetry, thermogravimetry, and the last one is precipitation gravimetry. In this experiment, Fe2 is oxidized to Fe3 and precipitated as hydrated ferric trioxide Fe to O3 as HO2. The precipitate is filtered to convert it to ferric oxides.
Next is the procedure. The first procedure is precipitations. First step, 25 ml solutions of iron was pipetted into 400 ml beaker and it was closed in wash glass. Second, 25 ml of distilled water was added to Fe solution using measuring cylinder and was heated until it boiled. Third step is 1 ml concentrated hydrochloric acid was added slowly drop by drop. Then the solution was continued boiling until it became clear yellow. Step number 4 is the solution was diluted to 200 ml mark with distilled water and was continued heated and boiled. Last step is the beaker was taken to the fume hood and 1 ammonia solution was added slowly and carefully until there is an excess. Second procedure is ignition and weighing crucible. First step, the crucible was cleaned and ignited for 10 minutes in the furnace. Then it was cooled in a desiccator to room temperature. Second, after cooling to room temperature, the crucible was held using tongue and the empty crucible was weighed accurately. Third procedure is filtering and washing the precipitate. First step, the supernatant solution carefully decayed through edgeless filter paper without stirring the precipitate at the bottom of the beaker from precipitation procedure. Second step, the precipitate was left as much as possible in the beaker. Then the precipitate was washed with 30 ml warm 100% of NH4NO3 used for each washing. The washing was repeated twice. Third step, all the precipitate was transferred to the filter paper. Wash bottle and glass rod used for this purpose. Last step is the precipitate in the filter paper was washed with 10 ml of warm distilled water until the filtrate is free from the chloride ions. It is tested with acidic silver nitrate. Last procedure is ignition and weighing precipitate. First step, the precipitate was slowly transferred with the filter paper into the crucible that we had heated earlier. Second, the crucible with the precipitate then was heated in the furnace at 500 degrees for 3 to 5 hours to constant weight.
Okay, now I'm gonna show you guys is a simple example of the calculation. First, we're gonna assume that the empty crucible that we measure is for 59.0843 gram, and then we're gonna measure the crucible with the precipitate, which is we're gonna run 3 times. For the first reading, we get 59.23171 gram, and for the second one is 59.2320. And for the third time is 49.2295 gram. Okay, after we get the reading, we're gonna search for the precipitate weight, which is we're gonna minus the crucible with precipitate weight with a empty crucible weight. So after we get that weight of the precipitate, we're gonna take an average, which is we sum them up and divide by 3. For the final value, we get 0.1486 gram. Now we're gonna calculate the mole of the precipitate, which is Fe2O3. Okay, now we know the mass of the precipitate that we calculate just now is 0.1468 gram. So we're gonna divide by the molar mass, which is 159.8 gram mole power of negative 1, which is we're gonna get is 9.19 times 10 negative power of negative 4 mole. So we get the mole of precipitate. We can calculate the mass of iron, which is Fe2+. So this is the half equation for the precipitate. So we know that 1 mole of Fe2O3 is equal to 2 mole of Fe3+. So we can calculate that 9.19 times 10 power of negative 4 is same to 9.19 times 10 power of negative 4 times 2. So we can get the mass of the Fe3+ is 1.84 times 10 power of negative 3. Okay, now for the result, we're gonna calculate the percentage of Fe2+. We know that mass of Fe2+, which is we calculate before, is 0.1029 gram. Now we're gonna divide by the volume of precipitate that we use is 25 milliliter and times with 100. So we're gonna get the value of 0.41%. So 0.41% of Fe2+ that involved in the precipitate.
Next, I'm going to explain the theory of gravimetric analysis. The principle of gravimetric analysis is to determine the amount of a substance by isolating it as a pure precipitate and measuring its mass accurately. It relies on precise precipitation, filtration, and weighing techniques to achieve accurate results. Next, we have 4 types of gravimetric analysis. First is precipitation method. Precipitation gravimetric use a precipitation reaction to separate ion from a solution. Second, volatilization method. The sample is heated or chemically broken down to separate the component of our mixture. Thirdly, thermogravimetric method. In this, the mass of the sample is determined based on the observed change in chemical and physical properties. Lastly, electrogravimetric method. The principles of electrogravimetry is similar to electroplating. Here, the metal ions are isolated from the solution by depositing on the surface of the electrode. Next, the advantage of gravimetric analysis. The result is more accurate and precise than volumetric analysis, and no need for calibration and no standardized required, and also can be applied to macro, which is large sample. For this advantage of gravimetric analysis is for single element, has minor misstep, will not produce a pure sample. This analysis need higher concentration sample and have many steps of heating and drying. Next, I will pass the presentation to Izati.
In conclusions, the gravimetric analysis successfully determines the amount of ions Fe present in the ion solutions. Based on the experiments, the mass of Fe in the sample can be calculated by determining the mass of final precipitates Fe2O3 and converting it. So, the corresponding mass of Fe using the stoichiometry of the chemical reaction involved. Gravimetric analysis proved effective in accurately determining the Fe contents in the solutions. It is important to consider limitations and source of error.